Okay, so in this one, review number 6, we are using a calculator, I guess, because it says window to see the graph. So let me open up my calculator here, and let's graph the thing. So y equals 5x to the third plus 13x squared minus 42x plus 30. And then we'll just graph it in the standard window and see what this thing looks like. Okay, so it looks like it probably does something like this, but we need to be able to see up higher here. So let's zoom out a bit, or let's do window. And in order to do this, here, let me go back to it. We need to see the top part of the graph. So I'm going to extend how high up my y max is. So I'll make the y max, I don't know, let's go really high and then see if we need to adjust it. So if I go from -10 to 100, I don't want tick marks every 1 unit. Let's make our tick marks every 10 units. So let's graph that and see how that looks. Oh, I still need to go higher. Okay, so let's do, I don't know, let's do 150 for the y max. 150 graph. All right, that's what I'm talking about. All right, so the window, the x min was -10. The x max was 10. I don't care about the scale anyway. That doesn't actually change the picture. It just tells you how often the tick marks happen. The y min was -10, and the y max was 150, and the y scale was every 10 units there's a tick mark. Okay, so that's that. Relative maximum. Okay, so a relative maximum just means any maximum point. Because really, this graph has no total maximum because it keeps going up forever. But a relative maximum just means any peak. So that's the peak that we want because there's only one. So remember that the calc menu is pretty much your best friend for graphs. So if I go to second calc, there's number 4, maximum. Then it's going to ask a few questions. What's on the left of the maximum? So you can see the cursor's here right now. I need to get it until it's on the left side of the max. And anywhere on the left is fine. So that's a good spot. And I'll hit enter. And then let me come over to the right side and hit enter, because now it says right bound, and hit enter. And then guess, and we'll just put it somewhere in the middle. That looks like it's close. And I'll hit enter. And the maximum is right here. So relative maximum, round answers to the nearest hundredth. So that would be -2.75, comma, 139.83. Okay, so my relative minimum is down here. So I'm going to go back to second calc, minimum. And, well, you can move the cursor if you want, but one nice thing is whenever it says left bound, well, I know that 0 is on the left side, so I can just actually hit 0 and hit enter. And then these are going by 1, so 5, I'll do 4. 4 is definitely on the right side, enter. And then I'll guess that it's around 1. And that just really tells it where to search around. Okay, so there's my minimum, 1.0, where is it? 1.02 if we round to the nearest hundredth, and 5.99. Okay, the zeros. So let's go back to the graph. There's only 1 0 here. Notice the minimum was actually right around 6, so that doesn't touch the x-axis there. So I only get 1 0, and it's right here. It looks like it's right around -5. Let's go second calc, 0. And I need to mark it on the left and the right side of the 0. Now, I said it was around -5, so I'm going to go left bound is -6, and right bound is -4. and then we'll hit enter, and I'll guess that it's at -5. And it's actually at -4.67. So 0 is at x equals -4.67. Leading coefficient, well, that you don't need the calculator for. Leading coefficient comes from the dominant term here. That's a 5. The degree is the biggest power, so that's 3. If we classify by degree, well, that's the special term for it. That's a cubic polynomial. Number of terms, 1, 2, 3, 4 terms. If you classify by number of terms, well, first there's monomial, then binomial, then trinomial. I've never heard of anything called a quartnomial or quadnomial. Once you get past 3, it's a 4-term polynomial, or a 5-term or whatever. And then the end behavior, that's the stuff as x goes to -infinity, then y goes to blank. And as x goes to +infinity, then y goes to blank. And so you can do this two ways. One way is you could look at the graph and say, well, look, as I get further and further to the left, so as x goes to -infinity, y goes downwards. So that goes to -infinity. And then as x goes to +infinity, well, y goes upwards. So y goes to +infinity. But you can also do this without even knowing what the picture looks like. So let me just close that. You can also get it from the dominant term, the term that has the biggest power. So if you just look at the dominant term, just imagine what happens if you had a really negative number in there for x. So if x was like -1,000,000 and then you cube it, it's an even more negative number. And then you multiply it by 5, it's still really, really, really negative. So that goes to -infinity. And then if you plugged in some massive number like 10 million or a billion or even bigger numbers and you cube it, it gets even bigger. And then you multiply it by 5, it gets even bigger than that. So that goes to +infinity. Okay, and then that's it. I hope that helps.